Today we're going to be working with solving logarithms using exponentials, and these are going to be just a step above what we've done previously when we were solving exponentials and logarithms. So first you'll notice that we have some logarithms, and on the inside of your log is actually going to be some sort of binomial. Now, if the binomial is alone, like if you have just only one logarithm in sight, we don't have to use the properties of logs, which will show you what like number 2 would happen if you do have more than one log. So let's try out number 1 first. So again, just like we've done previously when we were solving for exponentials, we want to get it so that your logarithm is alone and on one side. And then we want to match its base or use the swoop method. So I'm just going to be from here on out using the inverse property. So I'm just going to write the matching base of 3 here. So now that they match, I do it to the other side as well. So therefore, my log base 3 cancels and this drops. We have 9x plus 2 is now equal to 3 to the 4th, which is equal to 81. Then we can go ahead and solve for x as you normally would with any sort of linear. So that just means subtracting 2 to the other side. So you're left with 79. Divide 9. X is equal to 79 over 9. Let's try it again with the one below it. So we'll do a couple where we just kind of apply these basic rules. So we'll do 4, 3, and 6 maybe, or maybe just 3 and 4, and maybe you guys try out 8 and 6 here, and I'll show the answer key at the very end. We also have this one here, 9 as well. So let's go ahead and do number 4. So we talked about natural log and its base. Its hidden base, because they don't write it, is going to be e. So we're going to write e on both sides. What that allows us to do is it cancels out with your natural log. We have 4x minus 1 is equal to e cubed. So then we can go ahead and solve for your x value now by adding 1 to both sides, dividing by 4. So you have x is equal to e cubed plus 1 over 4. Now this is considered your exact number or your exact solution. So without evaluating it into a calculator, because e is already a specific number, so it's roughly 2.72-ish or 2.781. So when it's cubed, it'll be even bigger. So your approximated solution, if we were interested in finding it, e is located on the left-hand side, and we were going to, we did have a numerator, so let's put a parentheses to start. We're going to hit second ln located on the left-hand side of your calculator, and then we are raising it to the 3rd power. We said plus 1, close your parentheses, and then divide by 4. So your approximated solution here is 5.27-ish. So your approximated is 5.27. So this is approximate or an estimated solution. I'll do one more. Let's do number 3. So again, we don't have a base here. This is called a common log, which we talked about last time, which its hidden base is actually a 10. So if they don't write the base, it's assumed that this is a base of 10. So we write 10 on both sides. That allows us to cancel your log. That drops 5x minus 11 is equal to 10 squared, which is 100. Now we can go ahead and solve for x. So 5x, so subtract 111, we get 89, divide by 5. So x is equal to 89 over 5. So some good ones to practice from there is 6, 9, and 8. Now let's take a look at some special cases over here. We have the logarithm where we have 2 logs this time. So I'll highlight them here. And they both thankfully have the equal matching bases, so that's key. And it just says, okay, well, based on your properties of logs, so I'll probably write it up here. So your properties of logs, if we have log of x plus log of y, your properties of logarithms mean that we can actually combine them because they are the exact same base here. Maybe I even write a different base, just b. We can combine them under one log by multiplying x times y. So we can condense it. Now we can do the same if they were subtracted. If they're subtracted, we're not going to multiply, but instead we would divide. So x divided by y. And your last property is if we had k, some constant on the outside. When we go to rewrite it, this becomes the exponent of your log or of your variable. So those are some quick explanations of your properties of logs. So you'll notice here that we do have an addition sign. So that just means that when we go to combine them, we write one of your log base 4s. We can combine these to multiply. X times x minus 6 is equal to 2. Now, I would simplify before we get started next. So let's simplify on the inside. We have log base 4 of x squared minus x, or minus 6x, is equal to 2. Now that your logarithm is alone and on one side, we can go ahead and use your inverse property or your swoop method. So we're going to write a 4 on either side. That allows us to cancel and this drops. So we're left with x squared minus 6x is equal to 4 squared, which is 16. Now, have you seen something like this before in previous lectures or previous videos? Well, it's a quadratic, so we want to start to solve a quadratic by bringing over your 16 to the other side and actually go ahead and factor. So to factor, which I'll ask you to pause the video before I show you your factor. So you have x minus 8 and x plus 2 is equal to 0. Therefore, x is either equal to 8 or a negative 2. Now, logarithms, right? Logarithms cannot be negative on the inside because of its graph. Your graph of your logarithm looks like this. Y is equal to log of x. Notice that you do not have any x values that are negative, and also there is a horizontal or a vertical asymptote when x is equal to 0. So there are some restrictions when it comes to your logarithm. Now, we can always test that by bringing it in. So you have negative 2 minus 6. That'll be log base 4 of negative 8. And again, log base 4 of negative 2, right? So you cannot evaluate when it's negative. So instead, right, it'll just be one of your solutions. And you'll notice that we have one solution, one x-intercept here. So when we go to plug it in, so you have log base 4 of, let's see, 8 plus log base 4 of 2. So we just have log base 4 of 16 is equal to 2. So that just means if we were to swoop, 4 squared is equal to 16. So make sure that we need to just cancel out your negative, and then to check your solution, it is perfectly fine. Let's try it again with, let's see, a next one. Let's do number 7. So again, you'll notice that we have an addition sign. So let's go ahead and bring these logarithms of base 6 together. We have x plus 5 is equal to 2, 6, x squared plus 5x is equal to 2. Now that your logarithm is alone and on one side, let's go ahead and take the same base on either side. Allows us to cancel. You're left with x squared plus 5x is equal to 36. So 6 squared is 36. Now let's go ahead and get your 36 to one side. So notice that it is very, very repetitive, right? You go from 2 logarithms of the equal base into 1 logarithm. You multiply, you then drop your logarithm off by taking the same base. You then have a quadratic, so we're going to solve for your quadratic function. So now we're looking for 36. So let's see, factors of 36, that would be 4 and 9. So a positive 9 and a negative 4 is equal to 0. So x is equal to either a negative 9 or a positive 4. And we said logarithms cannot be negative. So we can go ahead and scratch out x is equal to 9. And let's go ahead and just quickly check your solution here by plugging it back into the original. So you have log 6 of 4 plus log 6 of 4 plus 5 is equal to 2. Log 6 of 4 plus log 6 of 9 is equal to 2. Log 6 of, let's see, 4 times 9 is 36 is equal to 2. So whether you swoop or you like to do the same base, so we have 6 squared is equal to 36, which is a true statement. All right, now let's see one that's a little bit more in depth. So now we have, again, 2 logs, equal base. They are being subtracted. So we can go ahead and bring them together. So we have x minus 1, or sorry, x plus 1 over x minus 4 is equal to 3. All right, so now let's simplify here. And I know these x's don't cancel and make negative 1/4, right? They can only cancel when they are the exact same. So at this point, we are going to want to either swoop or take the logarithm, take the exponential of the same base. The reason why is that we need to start to get this this denominator out, and the only way to do that is to get rid of your logarithm. So we're going to take the log of both sides here, the exponent of both sides. So you have x plus 1 over x minus 4 is equal to 2 cubed, which is 8. Now to get your denominator out, to get your binomial out of the denominator, we'll multiply it by each side. So we'll say x minus 4, that'll allow us to cancel, and put it on the other side. So we have 8x minus 32. And now that it's a linear problem, let's go ahead and subtract 8 to the other side, or get your x values to one side. So maybe we actually add 32, subtract x. So we have 33 is equal to 7x. Therefore, x is equal to 7 over 33. And again, we can check your solution by plugging it back in if we want. But as long as it's positive, it should work. Let's see, log base 2 of 7 over 33 plus 33 over 33. So we have log base 2 of, let's see, that's 40 over 33 minus, let's see, 7 over 33 minus, let's see, 4 over 1. Oh man, that is gonna be a pain in the bum. 33 times 4, that is 132 minus, let's say, 7 minus 132. Right, so let's bring those two together. So 4 over 33 divided by, so times 33 over negative 125. Those will cancel. Log 2 of negative 40 over 125. I think I did something wrong here because we should not be evaluating a negative logarithm. Let's see, is equal to 3. So this one actually might be a no solution. So we have 6. Oh yeah, this one might be a no solution. So notice on this one that we do end up with a negative on the inside of your logarithm. So it will look like this is going to be a no solution or an imaginary solution. Even though that when you do have it, it's positive, but when you go to evaluate it, 7 over 33 minus 4, that'll end up with a negative logarithm over here. So when you divide by that negative. So this one actually might have no solution. All right, so hopefully that video was informative. Make sure you are checking your solutions as much as you can. Again, you have some practice ones, and I'll show you the answer key here. And good luck.